Hello, my name is Darren Thomas, and I'm the Director of Educational Research Techniques. We are now in Unit 3 of Easier, Practical Applications of Machine Learning Algorithms in R, and we're looking at Lesson 1 right now. And so we're doing an overview of random forests. So in this particular unit, you can see that there are 5 lessons. We're going to talk about what random forest is, how it works. We're going to talk about data preparation, how to prepare the data, the unique data that we're using for this particular example. And then we're going to do 2 types of models. In lessons 3 and 4, we're going to take a look at classification, developing a model in lesson 3, testing a model in 4. And then in lesson 5, because you're already kind of familiar with the process, we're going to develop and test a regression model using random forests. So having said that, we're going to go ahead and focus specifically now on the overview of random forests. So one of the main problems that we have when we're dealing with decision trees is overfitting. This is a major problem. And by overfitting, basically what happens is that the decision tree just kind of memorizes the characteristics of that particular data set, and so you're not able to apply that tree in other situations. It'll only work on the one set of data that you trained it on. Now, to get around this, one of the things that random forest does is that it aggregates or it creates multiple trees. In other words, instead of having just one tree that's trying to deal with all the data, it makes many different types of trees, and then it aggregates the results, or finds the average for them or whatever. And so what happens is that what makes random forest random is one of 2 things. You can see right here, what makes it random is the sample. So it uses some of the data it does not use, and also the variables that are included in the model. All these things are kind of calculated for you automatically by the algorithm. Yes, you can adjust them, but what's constantly happening when you're making a random forest model is that you are randomly sampling from the data, and you are also randomly using different variables to create a tree, and then these things are aggregated. Now, in terms of aggregating, there are of course many different ways to do it, but you have to keep in mind the 2 purposes of a random forest algorithm. And of course, one is classification, and the other one is the mean for regression. So if your goal is classifications, in other words, you have a categorical dependent variable, then when we aggregate, we're just going to do votes. So whatever category has the most votes, that will be the prediction in that particular situation. When you're doing regression, or when you're trying to do a numeric prediction, again, in that situation, the different values for the different trees are the mean is calculated for those values. And when you use these 2 things, you are able to reduce bias and variance. Bias is when your model does not listen to the data, and variance is when your model listens too much to the data. That's kind of what's happening. And of course, with all algorithms, there are pros and cons. So the pros of random forest is that you are able to reduce the bias and the variance, that particular problem. However, the con is because you're making multiple trees and the results are being aggregated, you lose the power of the visualization that is available to you when you are using decision trees. There's no way to visualize. If you make several hundred trees, you cannot visualize that. It's not practical. So that is kind of the problem. And so what happens is that it's much more difficult to explain or to interpret the results for yourself, and especially for a wider audience who may not be familiar with the details of the statistical analysis of random forest. That's something to keep in mind. So essentially, we have given you an overview of the big picture of what random forest is about, making multiple decision trees, aggregating the results to get a much more stronger predictor model. And so we will now move to data preparation. So my name is Darren Thomas. This is Easier, Practical Applications of Machine Learning Algorithms in R. We'll see you in the next video.